Let us discuss about the expression for internal resistance in terms of EMF and terminal potential. Suppose we have a cell, let this be a cell of EMF E and internal resistance R. This unit I represented using this dotted line, dotted rectangle represents a cell having internal resistance and EMF. Suppose this cell is connected with an external resistance, let's say an external resistance R, then we need to find the expression for the small letter r in terms of R and E. For that, we have this side of the cell is the positive terminal and this side is the negative terminal. So current originate from the positive terminal and it move like this. I passes through the external resistance and come back to the negative side. And from the diagram itself, it is clear that current flowing through the external resistance R and the internal resistance R, small letter r, remains the same. So this R, external resistance R and the internal resistance R are in series. They are in series combination. So the current will be, or you can say the effective resistance R effective will be, for the series connection, it will be sum of the resistors R plus R. So the current in the circuit will be the EMF, that is voltage. Current is always voltage divided by the effective resistance. Clear? Here the voltage is E and the effective resistance is R plus R. So the expression for the current is I is equal to E divided by R plus R. Let's call that as equation number 1. Now we have the potential drop or the potential difference across the external resistance R is equal to, let's say we call that as potential difference as V is equal to, we know potential difference V is equal to I into R, the current flowing through the value of resistor. That is, potential difference across this external resistance is equal to current into the value of the resistance. And we know this V is the terminal potential. This potential difference is also the terminal, let's say, terminal potential. We already discussed about this thing for terminal potential, because although the cell is able to provide an EMF of E, we get a voltage less than this E, and thus that potential is called the terminal potential. So terminal potential V is equal to, here you know I is equal to E divided by R plus R times the external resistance R. Instead of I can put E by R plus R. So this is the expression for the terminal potential. Clear? Now, let's say, again take this equation. We have V is equal to ER divided by R plus R. And if you take this to the left, then R plus R will be ER divided by V. Clear? Taking this R plus R to the left and V to the denominator implies R will be, taking this R to the right, it is equal to ER by V minus R. Clear? Now the expression will become the internal resistance R is equal to, you can take this, R is common here, capital R is common here. So E by V minus 1 times R. So this is the relationship between the internal resistance and external resistance, where EMF is E is the EMF, V is the terminal potential. Clear?